Hello everyone, welcome back to my YouTube channel. Myself Nanes. I am studying in Shivrateshwara College of Engineering in the Department of Information Science and Engineering in 4th SEM ISC. Today's subject, discrete mathematics and structure. In that topic, cosets and Lagrange's theorem. Introduction. This presentation explores the concepts of cosets and Lagrange's theorem in group theory, providing essential insights into their definitions, properties and applications. First one, cosets. Definition and types of cosets. Cosets are a method a partitioning a group into equal sized subsets. Based on subgroup, give a group G and subgroup that left cosets are defined as, for example, G of H G for all G, and right cosets are H of G and G of G. There are two main types, left and right cosets, which differ based on the order of multiplication. Properties of cosets. Cosets have several important properties. They either do not overlap or are identical. Thus, any two cosets must be either distinct or the same. Additionally, the number of distinct cosets of a subgroup H in G is equal to the index of H in G, denoted as G of H. This index reflects the relationship between the subgroup and the group. Applications of cosets in the group theory. Cosets play a critical role in understanding the structure of groups. They are used to simplify complex group operations or provide insights into the relationships between various subgroups. Cosets are fundamental in deriving other important results in group theory, such as the classification of groups and the computation of quotient groups. Topic 2, Lagrange's theorem. Statement of Lagrange's theorem. Lagrange's theorem states that the order number of elements of a subgroup H of a finite group G divides the order of the group G. This foundational theorem links group structure and subgroup size, establishing that if G of G is the order of G and H is order of H, then G is equal to G of H star H. G of H is index of H in G. Proofs of Lagrange's theorem. The proof of Lagrange's theorem generally involves demonstrating that the left cosets of H partition the group of G into distinct subsets by considering the action of the group on itself, while left multiplication by elements of G. It can be shown that each coset has the same number of elements as H. Hence, the number of distinct cosets represented by the index GH must multiply with the size of H to yield the size of G. Implementations of Lagrange's theorem in group theory. Lagrange's theorem has several significant implementations in groups theory. It helps in determining the possible orders of subgroups, which in turn aids in classifying finite groups. Additionally, it implies that if a group has a prime order, then it must be cyclic, and every subgroup of such a group is normal. This theorem is foundational in proofs and further developments in group theory, influencing many branches of mathematics. Conclusion. In conclusion, the study of cosets and Lagrange's theorem provides a valuable insights into the structure and classification of groups. These concepts are functional in abstract algebra and have broad applications across the various fields of mathematics, reinforcing the interconnected